So hi, my name is Farid. This is the idea behind this tutorial is just to show you the approach and how to try to expand the custom Whitewater solver. Of course, it's not my idea. I get it from other tutors that are better than me, but just want to expand the the setup and as I said, the workflow for the people who want to try it. And so I decided also to make it from scratch so that you can follow along and maybe learn something, So we just started by doing from using the shell, because the idea is not the flips on the point is the whitewater. So just use the flip tank, so control click and you get some kind of made ready heading. We're gonna make it a little bit maybe short and taller, maybe longer, something like this, because I want the ball, so I'm going to make a ball go through the fluid and cause some white water, right? So we have now the initial setup, so we're gonna go outside. So for the flip tutorial we don't need it, we just the flip initial, the auto top and the flip tank. So first things I'm going to use a geometry and call it collision, something like this. This is a collision. So and in this collision it will be very simple sphere. So we're gonna use sphere, create something like this. Let me see all the objects so that I can position it, and we're gonna use the transform, of course, to just to put it a little bit in the middle. So let me so we're gonna start outside. Okay, they are moving the x-axis, so we're gonna see a little bit further. Let me stop the calculation by hitting this button, this brain button. So we're gonna move a little bit in time and put a key there, and then a little bit down, move it back, key, and a little bit on time in 20, something like this, and move it again and put a key. So in this case we have some, just some movement to get started. We change the frame. We don't want 200, we just want 120. This is for the sake of this tutorial. All right, we have so let us put null, or before the null we want a collision source, so just to use the collision. So it's easy because it calculates for me the VDB, and he put also calculate the velocity also, and make the blend, the interpolation, and all this kind of things quickly. So we're going to use the two nodes. One is the geo, one is the VDB. So we're going to call this one VDB, VDB, and this one is the geo something, So what I did, VDB, and this one is geometry, so geo. So we copy one of them. Copy. We go outside. Now we go and flip is very simple flip, nothing special. We just want static object, and it is a static object. We can bring our geo, and in the collision we're going to use the volume sample, and we call it it's the VDB one. Okay, so collision VDB, just to check the collision. I just want to see if I can see the collision. Of course we hide the object, we don't see nothing because the brain is, so you move one frame maybe, and you're gonna see the nothing. I didn't plug it. Let's switch the input and go back to one, and now you can see the collision is working. Okay, display, going back. So now we're gonna let it calculate. It will calculate quickly. No, don't calculate, because forget to set up the use deforming, because they are deforming or translated in the object level. And so now you can see there is a, let us a little bit up the 0.3, maybe something, that's too much, 0.5, 4, something like that. How much point? Something like that, so that we can see some movement in the islet. So now we can take a look at the they're moving and causing some turbulence and kind of things. So I forgot something. I just want to use the vorticity, so I have to add it. You need always the vorticity and the ID maybe, or the edge, to tweak further tweak the behavior of the fluid. But anyway, we just need the vorticity because I want to make it the emission criteria after in the Whitewater. So again, let's calculate the flip again with the vorticity on. Okay, now we have vorticity. Let us take a look at the that movements and vorticity. Now if I go back to the flip fluid, where you get all these fancy setup for the meshing, you know, but I don't need anything. I just need the, I didn't cache it because it's very light, so I don't want particle, I just want particle. And take a look at the vorticity. For example, you can see I have the vorticity here and the velocity also. So we gonna use a null because I want to import the the surface and the velocity and also the point to another level. So we copy this and we go back from shut the, you don't need the collision, we don't need. We're gonna make another geo and we call it VVV. So for the Whitewater, we go inside, we saw object merge, right, and we merge the surface with the velocity. Again, we need some blast node. We need 3 of them, or maybe 2 of them. We need the one is we want to extract the surface. We don't delete. So we have the surface. The second one is the velocity, and so we have the vel. So we have the velocity and the vel. You don't see them because they are volume. You need the volume visualizer, but we don't care. So next thing is that we have to unpack the point. No, unpack the point so that we can use we use them because in moment they are packed geo, as you can see. So you can unpack the point, and now I have the point, only the point. Here I have so we can name this surface and stick to organization, and we want to call this velocity. So we have the point, we have the surface, as you can see down here, and we have the velocity, which is a vector. So for the point, what we're going to use, we're going to use a simple trick, so VOP attribute, just to extract some point to emit from, and we're going to use the vorticity, as you can guess. Because that's why we calculate the velocity. It's good. We need it also for the shading and so, but many times for the criteria you use the acceleration, you use the speed, you use the velocity, vorticity, and this kind of information. We need a fit range, so we're gonna fit range it. So I'm gonna put it first in the CD so that we can see what's happened. As soon as I play, you can see nothing is happening because here I don't say vorticity. Vorticity. So not vorticity. I write it in vorticity. You just write it in now. So now you have some color changes depend on the vorticity, which you can you can take a look inside here, which is the big value, which is 29 or something like this, or maybe more. Yeah, the big value is twitching 40 in this case. No more, I think more. No, it's 40 something. Oh, 84. Anyway, we just want to